Okay, so in the last video I gave you a overview of the theory of sysfs, udev and dbus. In this video I'm going to actually show you things in the command line. So on our root file system you can see that we have a /dev directory. We also have a /sys directory, and there's also a proc directory. So first of all, I will show you the proc directory, and in here you can see that there's a bunch of files. So all these numbers that look really weird and confusing, they're actually process IDs, okay? So every application that runs gets a directory in here with information about the running process. Now over here you also see things like CMD line, CPU info, disk stats, you should have mem info, yep, modules, the kernel modules that are running. So you also have hardware related events. So you can see that it's a bit of a mess, and if the kernel developers wanted to keep adding stuff in, this would get very cluttered, and there's no real logical order to the way things are in here. It's just like file names. So that's why the sysfs was created. But in here everything is plain text. So we go CMD line, which is a useful one to know. It shows you what boot parameters we used when the kernel loaded up. Cat CPU info will show you information about the CPU. So there's information in here about device files. Now what I will do is I'll just load up vim / test file. And let's edit it anyway. Alright. So now I'm going to press Control Z just to put that process in the background. So now if I go ps aux pipe and into grep and we search for vim, we can see that there's two processes running for vim. So I'm going to look at the 29864. So if we go into cd 29864, so that's the process ID directory in proc. So proc 29864, and if we cat the CMD line file, you can see that the command line that was used was vim home training test file to load that application up. So so every process that's running has all sorts of different information in here that you can find out about the process. Alright. Alright, so now if we go into the sys directory, which was the sysfs file system was added to the 2.5 kernel but used in production in the 2.6 kernels, you can see that it's a lot more logical. So you don't have files all over the place like you did with the proc directory, and it's only hardware related devices. So if we wanted to know about modules, for example, we could go into the module directory, and you can see in here that there's lots of different names for all the kernel modules that are running. So we could go into E1000, for example, which is our network card, and it has all sorts of informations in there. So if you wanted to know what parameters it had, you can see that there's this copy break which has a value of 256. So it's a lot more structured and can be used by user space applications to find out information about the system. And if you wanted to know more about this, the kernel developers actually have all sorts of documentation that you can read. And there's different articles, mainly for developers though. So in the bus you can see that there's the AC97, which will have to do with the sound card. And you can see in here just all the system information, and it's very, very logical. Now basically, as things are added or removed to the system, the kernel will modify that /sys directory with new information. So it'll add and delete things as devices are dynamically added or removed using hot plug devices. So it's not actually stored on the hard drive. This is an in-memory file system, and so is the proc file system. Now, I guess I should show you /dev quickly. So /dev, everything in here is created by udev. And if we look at SD devices, you can see that at the moment there is one storage device listed. So it's the SDA with two partitions, SDA1 and SDA2. Now, if we go into the disk directory, you can see in here that we can look at disks by ID, by label, or by UUID. Now if we go by UUID to ls-l, you can see in here that all of our disks that are on the system have like symbolic links. So this is the UUID, and it links back to SDA1. And that's handled by udev. So when you've got lots of different disks, especially with like external hard drives, you might plug one external hard drive in and it might become SDB. Then you could plug in another hard drive, it could become SDC, and the order that you plug them in could be different. So if you wanted to access the drives, you couldn't just have the /dev/SD whatever, because it could change. So it has all these IDs in there to help you control it. Now, as a system administrator, you could just use BLK ID to see what the block IDs are for different things. You can see in here that here's one of the block IDs. So the information is in the dev/disks though, if you wanted to look at it. Now, I'm going to plug in a, actually I'll show you LSBLK first. So LSBLK, you can see in here that we have SDA, SDA1, SDA2. We also have the VirtualBox editions mounted as well. So now I'm going to plug in a USB device. Okay, so I believe that it's now connected. So now we get this pop up here as well. Okay, so this basically, what happened is that the kernel detected that the USB stick was plugged into the computer. So then it updated the /sys directory with the information for that USB stick. And then it would send out notification events. It sends data across the netlink socket, which the udev daemon is listening on, and it says, there's a USB stick been added, and then it will look at the /etc/udev rules.d directory, and it will determine if there's any rules specific to that type of device. Now, if there is, it will follow the rules. If it's not, it'll just do the default behavior, and then it will create the devices in here. So we go LSSD asterisk. You can now see that there's an SDB device with one partition. So udev created that, and then udev would send out notification which the dbus daemon would get, and it would then send out notifications which this application has then used to pop up this dialog box. So I kind of hope that makes sense, but I can click eject or open with files. So if I click open with files, it will then pop up this graphical file browser. So it could be a music CD or a photo browsing application if it was an SD card with lots of photos on it, or if it's a music CD, then obviously different events would happen. But dbus gets those events from udev, and udev gets the notification from the sysfs changing, and the kernel also sending the notifications on the netlink socket. So one more thing that I will show you in this video. Actually, I'll do it in another video. I'll finish this video here so it doesn't get too long.